Welcome to your first video notes for Calculus 1. So what you're going to do is you're going to watch these videos, take notes. If you don't have the video notes printed off, that's okay. Just take notes on your own sheet of paper. The notes are for yourself, so do whatever works best for you, and then upload a picture of your video notes to the Canvas assignment, just so that I know you have done them. But again, take notes. That will be helpful for you. I'm not looking for a specific format or anything. So we're going to go ahead and jump in here. So what we're going to look at today is we're going to work on looking at limits graphically. And so we need to know what a limit is first. So let's look at this graph. And I'm going to ask you a few questions that I want you to try and answer before you listen to me answering them. So first of all, as the x values get closer to 1, what does it seem like the y values are getting closer to? So I like to think about this as if I'm driving a car on this graph, no matter which way I come along this graph, as the x values get closer to 1, the y values are getting closer to 0. So we could say 0 here. And then why don't you try these other ones here, and see what you think the answers to these are before you watch me do them. So maybe pause for a second, pause the video, and then start listening again. So as x approaches 2.5, y seems to be approaching maybe 1.5. It's a little bit hard to tell there. As x approaches 0, y seems to be approaching 0. As x approaches 3, this is interesting. You might have some questions about this one. You might have had different answers because there's a hole there. But if I jump on my graph, if I think about riding the graph like it's a roller coaster, my roller coaster, as x approaches 3, the roller coaster itself is getting closer to 1. Something funky happens at 3 itself, but as we're approaching 3, the y values are getting closer to 1. 3, the y value is -1, but as we approach 3, the y values are approaching 1. Okay. And as we approach 2, something real funky happens. So if I jump on my graph and ride kind of the roller coaster from this side, if I'm riding towards 2 from the left, the y values are approaching 1. So maybe you could say 1 as our answer here. If I jump on my graph on the right-hand side and I approach x equals 2 from the right, then my y values appear to be approaching 2. And then to make matters worse, the actual y value at 2 is 1.5. So you might say maybe it's 1.5. Let's just like average these values. What we're actually going to say here is that this value does not exist. We'll use D and E for that because what's happening is something different is happening on either side of 2, and we want to indicate that by does not exist. Okay, so we can formalize all of these things that we just did here. We call these limits. So a limit is essentially exactly what we're doing. A limit is asking, as the x values approach a certain value, what do the y values do of the function? So the way that we write this is we write this as the limit as x approaches a of f of x equals L. That's how you read that statement. This statement says that as x gets closer to a, then the y values get closer to L. Okay, so we could rewrite all of these ones that we did up here as limits. What we could say here is, if we call this function up here f, we can say that the limit as x approaches 1 of f of x is equal to 0. We could say that the limit as x approaches 2.5 of f of x is equal to 1.5. You could write b and c similarly. I'm not going to do that. Over here, we'll say that the limit as x approaches 2 of f of x, we'll just say that does not exist. Okay. So why don't you go ahead, stop the video here, look at the graph that I've given you now, and compute all of these limits here. Okay, I'm going to go ahead and keep recording, but you should stop and try them on your own before you watch my answers. Okay, so as x approaches -3, the y values on this graph are getting closer to 2. It's okay that there's a hole at 2 because, or at -3 too, because we don't care what happens at -3 itself. Limit just cares what happens near x equals -3. So it's saying as x approaches -3, not what happens at x equals -3. Okay. Let's see, as x approaches 0, something different is happening on either side. It looks like maybe we're going to 3, maybe we're going to 0. If something different's happening on either side, we say that this limit does not exist. As x approaches 1, that looks like it's probably 2. It's a little hard to read this from the graph, so if you said something a little different, that would be okay. As x approaches 2, the y values are getting closer to 1 because if I follow this graph on either side of 2, I get closer to 1. It does not matter for us right now that the actual y value at 2 is -1. So what we would say is that f of 2 is -1, but that's not the limit. The limit is 1. Okay, +1. As x approaches 5, the y values are approaching 3. So my graph on either side of 5 is getting closer to 3. And then as x approaches 6, on either side, the y values are getting closer to -infinity. Ooh, sorry about that. So we'll say that this is -infinity. Okay. So now I'm going to ask a question to lead us into another definition. So we noticed that at 0, we said that the limit did not exist because something different was happening on the left and the right of 0. And so we want to be able to like talk about this because like just saying the limit doesn't exist doesn't help us like understand what the graph looks like there. So what we're going to talk about in a minute is we're going to talk about left-hand limits and right-hand limits. So for part G, I'm saying as x approaches 0 from the left. So that means if my little roller coaster is starting to the left of 0 and approaching 0, what are the y values doing? They're getting closer to 0. So we're going to say 0 here. If I jump on the roller coaster to the right of 0 and get closer to 0, what are my y values doing? They're getting closer to 3. So we're going to say as x approaches 0 from the right, the limit is 3. Okay, on the next page, I'm going to write a definition here, but the way that we're going to write this is we're going to say the limit as x approaches 0 from the right, we're going to use a little plus sign, and this is going to be a superscript. So this is like a tiny little plus above here. So this is not saying +0, this is saying 0 with a superscript on it of f of x is equal to 3. And for the left-hand limit, the way we write this is we write the limit as x approaches 0 from the left is a negative superscript. This is not saying -0. This is saying 0 from the left. So you have to be careful where your negative sign is. Like if I looked at -3, that's saying x is approaching -3. If I write x approaches 3 with a negative up there, I'm saying x is approaching +3 from the left. Okay, so just be careful there. Okay. So that's left and right hand limits. So a left hand limit is just saying what happens as x approaches a from the left. So think about jumping on the roller coaster on the left hand side and approaching a particular value. Again, same notation that I talked about before. And so here you're just looking at x values less than a particular value. And then the right hand limit is saying start with numbers a little bit bigger than a and approach a. What is the limit going to be there? Okay. So now I'm going to give you a little bit of time to practice here. So try these problems, stop the video here, try these problems, and then start it again and listen to me answer. So stop the video now. Okay, I'll go ahead and jump into them now. Okay, so if x approaches -1 from the right, that means I start to the right of -1. So I'm going to start over here. I'm going to get closer to -1. My y values are getting closer to +1. So that limit would be 1. Notice here we couldn't ask about the left-hand limit at -1 because there's nothing to the left of -1. The function doesn't seem to exist there. Okay, so now the right-hand limit of +1. So I jump on the graph to the right of +1, and the values are approaching +1. Or no, they're approaching 0. Sorry. If I jump to the left-hand side of +1, and if I approach +1, y values are still getting closer to 0. We notice that the limit at +1, the limit as x approaches 1 of f of x is just 0. And the left and right hand limits are also both 0. That's good. If the overall limit is equal to 0, then the left and right hand limits should do the same thing. The only time then the left and right hand limits might do different things is if the overall limit does not exist. Okay, which I think we're going to see here in just a second. So if x approaches 2 from the left, if I start to the left of 2 and get closer to 2, the y values approach 1. If I look at the right-hand limit, x approaches 2 from the right, come from this way, the y values are approaching 2. We notice here that the limit as x approached just a plain old 2 without a left or a right hand limit on there. That did not exist. And the way that we can see that does not exist is that the left and right hand limits are not equal to each other. If the left and right hand limits were equal to each other, this limit would exist. Okay. Let's see. If we're approaching 3 from the right hand side, then my y values are approaching 1. And if I'm approaching 3 from the left hand side, my y values are also approaching 1. We see that the limit as x approaches 3 is 1, even though f of 3 is not 1. That's okay. And then if we approach 4 from the left-hand side, we're going to get 0 out here. Okay. And then one final question here. What we've noticed is that if the left and right hand limits are not equal to each other, then the overall limit without a left or a right is not going to exist. Because what's going to happen here is if my left and right hand limits are different values, then I'm going to get something that has some kind of jump. The open and closed circles, they could be different. They might both be open. One might be open, one might be closed. There might be a closed dot somewhere else. But either way, they're going to different values. So the limit as we approach that particular a value is going to be does not exist. Okay. What we'll do in class is we'll work a lot more problems like this. So you're going to get a lot more comfortability with it in class if you're not comfortable with it right now.